Hi everyone, my name is Lydia and this is what I wish they taught me about econometrics and introduction. In this video, we're going to see the continuous and continuous interaction worked example so that you can clearly see how marginal effects change with the z. We're going to stick to our usual model, y equals to beta 0, beta 1 x, beta 2 z, from where we know very clearly that the partial derivative of y with respect to x is equal simply to beta 1 plus beta 3 z. From here, we see that it depends on z, and that's where also the question of how does the marginal effects change with z stem from. So let's apply this with numbers and see with concrete numbers how the slope changes. For a moment, let's assume that the y is equal to 500 plus 20x plus 10z and 5x times z. Again, let us remind ourselves that x and z are both continuous variables. X is the years of education, which means it can be 2, 3, 4, and so on. And y is the years of experience, where it can be 2, 5, 10 years, and so on. And y being our income as usual. So if we write the marginal effect, just as we've done with the theoretical model, for this particular estimation model, we're going to have that the derivative of y with respect to x is now 20 plus 5 times z. So the return to education depends on experience, since the z is showing in here. Now, let's evaluate this at different values of z. So for instance, if we had z equal to 0 by simply substituting it in this derivative in here, so I'll put this delta y over delta x in here, and I'm just going to move this a little bit more down. So we have that when z is equal to 0, this derivative is simply 20, because it becomes 20 plus 5 times 0. When z, let's say, is equal to 2, then this will become 30, because we simply have 20 plus 5 times 2. And ultimately, when z is equal to 5, you'll find out that this is actually equal to 45, because it will come as 20 plus 5 times 5. Okay, so as experience is increasing, so in this direction, experience is increasing, we can also see that this derivative, this partial derivative, or the return to education, so when we go in this, so return to education also increases. Okay, so experience increasing, returns to education also increases. Now, what that means for us, because all of these numbers that we see in here in this table, especially on the column of the partial derivative, these are the slopes in a sense. So the slope, as we can see, it is not fixed. It changes with the z. This also means that this beta 3, meaning this 5 that we had estimated in here, is giving us a very important information in here. What it's telling us is that for each additional year of experience, that we have will increase the return to education by 5. So the emphasis, the highlight in here is on for each additional year of experience, okay? Which means that if it's 1 year of experience, the increase will be 5. But if it's more than 1, it means that number needs to be multiplied by the 5. Okay? So Now, let's look at flipping the interpretation. So let's look at it from the other perspective where we would have the derivative of y with respect to z. That should give us simply 10 plus 5x. Okay, so look again in here, the number, the slope that is attached to the x, because now the effect of z depends on x, is again a 5, which means that even in this case, the effect of experience depend on education, and there is an additional 5 for every year of education. Okay? And you can do exactly the same computations that we did in here in this table, but this time you can set the x equal to 0, x equal to 2, and x equal to 5, and find another column in here where you have the partial derivative with respect to z, and do the computations for yourselves to double check how exactly now the return to education is going to increase when years of education is increasing. Now, education and experience, what they are doing in this particular case is that they are reinforcing each other. The more experience you have, the more valuable the education becomes. And the more education you have, the more valuable the experience you have becomes. So interaction terms allow effects to change continuously across individuals. And in continuous times continuous interaction, the marginal effect of X varies smoothly with Z. Next, we'll step back and look at a key concept, how to compute and interpret marginal effects in all interaction models. So stay tuned and I'll see you in the next video.